So now let's talk about atomization and ionization. Okay, so this is a hydrogen molecule, and when I give it energy or when I give it electron energy, then what happens? The hydrogen molecule splits into two separate hydrogen atoms. Okay, now then these hydrogen atoms, when they when electrons are moving inside this tube, right, in like the cathode rays are nothing but electrons that are moving at high speed. So when electrons are moving at high speed, that means they have some energy. So whenever you have an object that is moving, any moving object has what we call as kinetic energy. So when these electrons are moving with high speed from cathode to anode, they have some kinetic energy, and this kinetic energy is passed on to the hydrogen gas atoms that are present inside this Crookes tube, and that energy is absorbed by these atoms, and you end up getting a hydrogen ion and one electron. This electron continues with the rest of the cathode rays, and the hydrogen ion goes in the opposite direction and they form the anode rays. Okay, that's what we learned in the last slide. So now what are the properties of anode rays? Anode rays also travel in straight lines just like the cathode rays. Anode rays contain positively charged particles. Unlike cathode rays contain negatively charged particles. Anode rays contains positively charged particle. They cause mechanical motion just like the cathode rays. Anode rays are deflected both in electric field as well as magnetic field just like the cathode rays. They cause heating effect, same, and they have kinetic energy just like cathode rays. The only major difference is that the E by M ratio, remember you calculated the E by M ratio. What is E by M ratio? Charge by mass. The charge by mass ratio of particles in the anode rays is not constant. In cathode rays, it is always constant. So remember we studied this. E by M ratio of cathode ray particle is always constant. You calculated this, you got the answer, and that ratio is always constant. It will never change for cathode rays. But for anode rays, that E by M ratio will depend on which gas is present inside the discharge tube. Here, when I was giving you an example, I used hydrogen gas, but I could use any other gas. Okay, I can use helium, I can use any other gas, not necessary that it is hydrogen gas. So in case, and only in case of anode rays, cathode rays is always constant, but anode rays, it depends on the nature of the gas that is taken inside the discharge tube.